Hi, this is a question out of your textbook on page 328, exercise 9.7, question number 13. We have a local bank in Edmonton. They're going to add 0.65% to the effective rate. This is the key word here, effective rate of interest on Mr. Smith's line of credit. If the current rate charged is 7.85% compounded quarterly, calculate the new nominal rate of interest compounded quarterly. I think what the key point here is that we're told that they're going to be adding 0.65% effective rate of interest on the line of credit, and yet the interest rate that is stated is 7.85% compounded quarterly. Now, we can't add apples to oranges, and so what we need to do is make sure that we're using the same types of rates, or at least rates that are compounded with the same frequencies. So we can only add apples to apples in this type of problem. So what we need to do is to convert the given rate of 7.85% compounded quarterly. We need to go from a 7.85% compounded quarterly to an equivalent effective rate. So once we convert to an effective rate, which means that we're converting to a rate compounded annually, once we convert it to an effective rate, we can then add the 0.65% that we are increasing it by, and then go back from an effective to a quarterly rate. Now, I'm going to be doing this problem algebraically, and I'm also going to be doing it using the built-in functions on your calculator so that you can compare the two solutions. They will end up being the same, of course. So let's start off with converting the rate that's compounded quarterly to the rate that is compounded annually. Effective always means compounded annually. So what we have is 7.85% compounded quarterly. So J4 is 7.85%, and what that means is that I'm going to have 1 plus my rate per quarter, compounded 4 times per year, because there are 4 quarters per year, should equal 1 plus my rate per year, compounded exactly once per year, since it's compounded annually. So what is the rate per quarter? In order to get the equivalent rate per quarter, what we have is 1 plus 0.0785 divided by 4 raised to the exponent 4, because there are 4 quarters in 1 year, will equal 1 plus my unknown rate per year compounded once. And so once you've divided that 0.0785 by 4 on your calculator, you will end up with 0.0196 and so on. So we'll have 1.019625 raised to the exponent 4 is equal to 1 plus I to the power of 1. This is a rate of a periodic rate of 1.9625% per quarterly period. When I compound this 4 times to cover the 1 year period, we end up with 1.08084, and I'm going to put squiggly here because there's a whole bunch of other stuff that's going to appear on your calculator display. That will equal 1 plus I to the power of 1. Do not clear your calculator at any intermediate step. Make sure that you retain all decimals. The next thing in solving for the interest rate per year, what we're going to do is we're going to subtract 1. So we have 1.08, whatever's on your calculator display, minus 1 is equal to I, so 0.08084 and so on is equal to the interest rate per year. And so what do we conclude? We conclude that 8.08 and so on percent per year, which is the same as effective, is equal to our stated rate of 7.85% compounded quarterly. So what's happening here is that now we can add the 0.65% effective, which means per year. We can now add that to this effective rate that we've just determined. So we've got 8.08 and so on percent per year. We can add 0.65% per year because that's what we're increasing the rate by. And we end up with a new rate of 8.73 and so on. So the new rate will be 8.73 and so on percent effective. And so on your calculator display, your display should actually have 0.0873, etc. per year. And so now what we need to do is to convert this into the equivalent rate compounded quarterly so that we can state what the new rate is going to be that is going to be charged on the line of credit. So now we need to convert to a compounded quarterly rate. So we go from effective to quarterly. In the first case, we went from a quarterly to effective. We increased it, and then we go back from effective to quarterly, which is what we started off with. So now we've got add 1 to this because we have 1 plus I, 1.0873, etc. to the exponent 1, because this is the rate per year, will equal 1 plus my rate per quarter for 4 quarters. Remember that we're converting to a per quarter rate. So what I need to do is to solve for I, and so what I need in this case is to eliminate the exponent of 4. So I'm going to raise both sides to the reciprocal power. I'm going to use the power of 1/4. So I'll have 1.0873, etc. to the exponent 1/4 is equal to 1 plus I per quarter. And once you've worked out what that exponent does to the base of 1.0873, it works out to be a value of 1.0211, etc., and that's equal to 1 plus I. Again, now what we're going to do is we're going to subtract 1 from that number on your calculator display. So we end up with 0.0211, etc., is equal to the interest rate per quarter. And so now this is our periodic rate, and we have to now convert that to the nominal rate compounded quarterly. So I'm going to multiply that by 4 to get the nominal rate. So we end up with 8.4618% compounded quarterly is the new rate that is being charged. And so now what I would like to do is to discuss the solution to this problem using the BA2 Plus built-in function calculator. Let's use the function called iConvert. iConvert actually does an interest rate conversion. Now if you search your calculator display, you will find iConvert, or interest rate conversion, right above the digit 2. And of course, since it's a secondary function, you will use the second function iConvert to access the interest rate conversion. And what's nice about this is that it converts any effective rate to a nominal rate, or alternately any nominal rate to an equivalent effective rate. So in this case, we're going to start off with 7.85% compounded quarterly. Now, compounded quarterly is a nominal rate compounded 4 times per year. So we're going to be using, on our calculator, we're going to be using second function iConvert. And from there, you will, I believe your default entry value will be nominal. And what you will do is enter the nominal rate, because that's what this is. This is a nominal rate. We will enter 7.85. because your calculator automatically assumes that any number that is entered is in percent form already. So 7.85 means 7.85%. Now remember, most importantly, to use the enter key, and the enter key is in the top row. So you're going to enter 7.85, so now you should see on your calculator display nominal equals 7.85. Now you're going to press the down arrow button, and when you press the down arrow button, you will see the words effective appear. Well, you don't know what the effective rate is, so you're going to press the down arrow button again. Ignore that value for the time being. The next entry that comes up is C/Y. C/Y means compounding periods per year. Well, because we're entering the compounding periods per year for our nominal rate, then that means that the compounding periods per year are 4, so you're going to enter 4 and remember to press the enter key. And now you will hit the down arrow button one more time, and you will see that nominal is still at 7.85. Skip that now and go right, press the down arrow button again and go down to effective. And once you've reached the effective entry, what you should do is press compute. CPT, press the compute key. Your calculator should display 8.084 and so on your calculator display. And so what you've concluded now is that 7.85% compounded quarterly is the same as or is equivalent to an effective rate of 8.084. Now on that display, you now realize that he is now currently being charged 8.084%. What you should do at this stage in time is just hit plus 0.65 to this number and hit equals. So now the new effective rate should equal 8.734 and so on. Remember, if your display is now reading effective and you've now calculated 8.734, you should remember to hit the enter key. So now you have now forced the new effective rate to be equal to 8.734. Press the enter button and press the cursor down key. You should pass by C/Y. It should equal to 4. If it doesn't, for some reason or odd reason, it should still be the same value as what you've entered before. Keep pressing the down arrow button until you come down to a nominal. And once you have gone down to nominal, what you should do is press compute. Because now what we want to do is we want to compute the nominal rate compounded quarterly that is the same as 8.734% compounded annually. So let's press the compute button, and your calculator will now compute the 8.4618 as the new compounded quarterly rate. And that's exactly the same answer that we had when we calculated it using algebraic techniques.